Okay everybody, today's video is going to be on tone remotes and how and why they're used and how you can test them. I'm going to start off with just an overlook at the equipment that we're going to be using in the video. What I have here is a console. It's a Vega C1616. It's a 6-channel 16 frequency console. For a tone remote, it can be really anything from a small 1-channel, 1 frequency to a giant console system. No matter which version it is, it always comes down to a single channel and down to a single pair of wires. So we have this console hooked up with a cable going over to our tone remote adapter panel, and the cable that's going over is going into an RJ45 breakout, and this is where we're hooking up our oscilloscope to look at the line and the signal coming out, going from the console over to the tone remote adapter. Let's start off with the whole grand purpose of what we're doing here. If you're a dispatch center, or even if you're just a local office and you have a radio that you need to control, whether it be in the closet down the hall or 300 miles away on a mountaintop, it doesn't really matter, as long as the levels are accounted for. This system will work no matter how far close the radio is to the console. But if you are a long distance away, or you need to talk on a radio, and that you have to be able to transmit and from a distance, because you're too far away for a local radio to work. And that's why we have the microwave system and telephone lines that we lease, and they're to provide virtual long wires that are essentially perfect with no loss. But that's what they're used for, is to provide long wires. Now if you're at the console and you have a radio that's at a mountaintop far away from you, you need to be able to control some things on that radio, but you only have 2 wires and you can only use sound to control it. So some of the things that you need to be able to control are making the radio transmit. You need to be able to change channels, and you need to be able to put it into monitor mode. So to give you an example, I'm going to come here and I have it hooked up now, and I'll show you when I transmit that I'm making the tone remote adapter key up, and when I release it lets go. If I change channels, it tracks whatever I change. If I need to put the radio into monitor mode, I can hit the monitor button, and I can get the monitor relay to click on and light up. Now, this adapter panel would normally be attached to a radio where the push-to-talk, monitor, and channel changes could be passed on from this box over onto the radio itself. I don't have a radio hooked up here because they all work the same as far as what they eventually do. Now, once again, I'm going to show how when we key up, you can see my voice over here on the oscilloscope, and channel changes and monitor function again. And now I'm going to change the focus to the oscilloscope, so that for the rest of the demonstration you can get a good look at the display and follow along with what I'm doing. So stand by for just a minute while I re-aim the camera. And hopefully that will be within the containment field. Okay. Now, I want to start off talking briefly about the oscilloscope. It's one of the most underused but most valuable, most powerful test equipment that you can have. And I would highly encourage any new technicians to really get familiar with oscilloscopes and how they work. It's our eyes to electricity, and we have lots of other test equipment that we routinely use that gets us by for the most part, but there are many times when the oscilloscope is the only answer. So if you've ever watched someone use an oscilloscope, one of the things you always wish they would do is show you what their screens look like in their setup, so that you could mimic them when you get back to your own oscilloscope. So to start off with, I just want to show you, I'm using channel 1. So if I come here to the channel 1 menu, you can see my settings: AC 20 megahertz bandwidth, times 1 probe, invert off, just very standard stuff. On my trigger menu, I'm using channel 1 for the source. I'm at edge, on the rising slope. I'm auto right now and AC coupling. Once again, I'll do a demonstration. 1, 2, 3, 4. There's my voice speaking. And I'll also show you the horizontal menu here. I have it in the window. Just keeps everything contained in the window. And then I also will be using my cursor screen here shortly when we get down to measuring some frequencies. But to start off with, I'm going to let's take a look at how exactly the tone remote makes the tone remote decoder do the things it does. And as I key on the transmitter here, you will see a series of tones and bursts. And what I want to do is I want to take a look at one of those up close, and you can see the pattern of how we're establishing the protocol to control. So one of the best functions of a newer scope is it has the ability to do essentially it takes a picture. It's a storage scope, and what it does, it takes almost like a /video/ picture of a electronic event, and it freezes it so that you can go back and look at it. And for this kind of purpose, we really need to have it, because the timings involved are everything that happens within a 1/7 of a second. It's so fast that you can't see anything and get any kind of reliable measurements just by looking at it live or hooking up any kind of test equipment. So we're going to start off with, I want to just show you a live one here using the normal push to talk, and we'll see what that looks like. So if I come over here and I'll go run, and we'll go single sequence, and here we go, and we have acquisition complete. Okay, so I don't like that one a lot right there. Let me do this. Let me take the microphone off, because the audio really makes the waveform get all jumbled. So just for demonstration purposes, I will do nice crystal clear tone remote. So here we go. And there we go. There is your classic, perfect waveform sample. And we're going to get into this and blow this up in just a second. But what I want to cover real fast are the main parts of it. This first group of signal right here, this first burst of tone, this is your high-level guard tone at 2175, and it's going for 100 milliseconds. And what that tone does is it tells this box, the Vega, to wake up. Something very important is about to come down next, and you need to have your ears on and pay attention, because the next thing that comes is going to be a command for you to do something. So this is the initial, hey, wake up, listen, get ready. The next part is the function tone, and it's 10 dB lower. And real quick, let's talk about these levels here. We're looking at the high level guard tone of being 0 dBm, which is like 2.1 volts peak to peak. And then the function tone lowers 10 dB to -10, which is 0.7 volts peak to peak. And then finally the low level guard tone, which is the tone that keeps the radio transmitting as long as you're pushing the button. It's at -20, which is 0.2 volts peak to peak, a tenth of your high level. So for every 20 dB of loss in power, you get a tenth of the voltage. So anyway, what we're going to do is I'm going to come over here and I'm going to zoom in on our signal so you can see what it looks like, and you'll see this transition. Here's the high level guard tone. This is where we shift to the function tone, and we're going to do this for 40 milliseconds. I should shorten it up here. There we go. And finally, we get over here to the 2175 at -20. So let's blow this back up again. Once again, 100 milliseconds of 0, 2175, 40 milliseconds of function tone, which in this case was a transmit on F15, and then we have the low level guard tone. Now, this is all happening, like I said, within a split second. So one of the things that techs are faced with is like, well, how if you think one is bad, or you think it's sending out the wrong function tone, is there any way to test it? Is there any way to see if it's really working the way it's supposed to? And yes, there is a way, and it's fairly easy if you got your oscilloscope hooked up right. It's a lot easier if you happen to have a spare DSP-223 laying around in the back of your truck that you could just easily plug in with a wall wart and plug in your RJ45 and test it, and you can look right away and say, oh, your function, you're transmitting on channel 8 on that one. But if you don't have one of these, or if you have one of these and it's not working and you suspect something's wrong, you can get in here with the oscilloscope and actually do a detailed analysis and confirm that each one of these frequencies are accurate and they're at the right level. So to do a demo, we're going to look at, we're going to change the frequency here, and we're going to look at and see if we can determine what the function tone frequency is and see if we can decode it. We'll see what it is here, but let's see if we can decode it using the oscilloscope and confirm that it was the same frequency. So if I come down here and I arm myself again and get ready for another burst, and I come over here and I do F3. And what I just did was the console just sent a command. First, it sent the 2175 high-level guard tone saying, "Wake up, DSP223, I have something important to tell you." And the next thing it sent was 40 milliseconds of a tone. In this particular case, it should have been 1750 hertz. And when it decoded that 1750 hertz, it said, "Oh, I know what that is, because in my programming table, I have 1750 associated with channel 3. So that's how it knew to change the control to channel 3. Now, if we want, we can go in here and look at this and see if we can't confirm that that was in fact 1750 that we sent. And if we come in here and we get in on our function tone portion of the screen and we blow it up and we get some bigger voltages here, and there we go. And if we come over here on our cursors, and I'm going to just take my cursor here, and what I'm looking to do, and this doesn't have to be exact because you'll know once you do the thing that, oh yeah, I'm about right there. What you want to do is you get your cursor in the middle of the waveform, and then get your other cursor in the middle of the next peak. And then if you get them centered up as best you possibly can, it's not exact science, but anyway, I seem to be piercing the two hearts of the things. If you look over here on my delta, you can see 1754 hertz. So this is where I could fine tune it in, but you get it. It's obviously not 1850, and it's obviously not 1650. So that's how you can get in here. And like I said, you can blow it up and get it super precise if you want, but for all intents and purposes, this can just be your sanity check of like, oh yeah, that's right, that's 1750. So if you had an unknown one, and for instance, let's do another one and see if we can repeat the process here, and turn our volts back down, and let's get centered back up. I'll do one more just to make it fair. Okay, and we're going to rearm, and we'll try this again, and try over at F15, and there we go. And we got acquire complete. Let us know that we were successful in capturing it. So let's go over here and see if we don't see a big change. Now, the function tone for 15 is really low in frequency. It's 550 hertz. So you see a dramatic change in our levels here. So once again, I'm going to try and measure this on the function tone and confirm that I got 550 hertz. Come over here and try and get the center of that mountain. Center of that mountain. 555, close enough for government work. So we'll call it good there. Once again, just a way that you can, if you need to, test a tone remote, that you can hook it up to an oscilloscope and get that fine measurement to confirm, and that not only you got the right signal, but that you have the right frequency, and that you also have the no distortion in your tone. And I could still do the same thing if I wanted to, just so you know. It's not only for the function tone, but you can do it for the guard tone too, if you're like suspicious of like, well, was that really 2175, or what exactly was that? So once again, let me see if I can get a good shot here. Get a couple in position. Sometimes when you're doing the freeze, the sample rate isn't the best, so you get, in live, this would be a sinusoidal form. When you do the samples, it kind of triangles up stuff, but the basic peaks and dips are about the same. So, but anyway, once again, you could do your whole just find your center your peaks and get a measurement for the best you can for the. Let's see if we can get somewhere in there. Let's see if we can get one like this. But basically what you're looking for is you're looking to center the two mountains, and you can just take whatever. So sometimes you got some jumble, so you might want to look around and find a couple that are more sequential. It's the higher frequencies that are a little bit more cumbersome than the function tone. And you can see on the function tones, they're a little bit more sinusoidal. But there you go. That's a way you can test it, and like I said, confirm everything is working. You don't have to guess. You can look for yourself. The only other thing I wanted to cover is just that on the interface from the DSP-2223 to the radio itself, this device here can put out its own PL tone programmable for each channel, or it can put out an actual logical channel change lines that can be hooked up if your radio has a remote channel change capability, which a lot of ours do. So it's got either option to let you make use if you only have a one channel radio, but you just need multiple CTCSS transmit tones to work. But other than that, this is it, and this is the workhorse of all of our radio systems out there. Probably 90% of them operate in this way with this format of tone remote control. So don't be afraid to get very deep into this and get super familiar with it so that you're very comfortable, and wish you the best. All right, thank you.